Thank you for joining me for this Coffee with the Editor with Railways Africa magazine. I'm joined by Andy this morning. He is the president of the Institution of Railway Signalling Engineers. Perhaps to give everybody a bit of a history.
We were incorporated on the 3rd of December 1912, and historically it was a group of engineers as they were then. They were very regional in the UK. And this was an institution that was built to further the science of signalling telecommunications, and they wished to further that and support the industry, and out of that we formed our articles of association. So we promptly became that type of organisation, and in organising the institution we have a council which includes membership levels, because we're split into member, fellow, associate.
So how did you land up here in South Africa?
South Africa was a region that was seen as it needed to be visited, and it's just right and proper that sometimes we come and see the places and see what challenges they've got, so we can link back to the HQ, which is fundamentally there to have a base of documentation, a base of knowledge and experience, to then say, well, if we've got these issues we need to look at doing this, or if we've got some direction that we can give.
Setting up the IRSE here in South Africa, when was that founded? Yeah.
It was May 1981.
Having just had your tour of some of our railway operations here, what are your thoughts of that?
Well, has to be said, these guys have done a fantastic job of hosting me to be able to see different facets of the organisation. And of course I'm based in the UK, and I touch base with a lot of other countries. In the UK we've gone through similar things that it seems that South Africa have gone through, but we've ended up with one infrastructure owner. One thing, and I mentioned this in our first technical day, I think for any country I would say this, that if you've got more than one infrastructure owner, it becomes quite a task to bring those people together. And in terms of our particular specialism, if you will, because we provide the control and safety systems for that infrastructure, it makes investment decisions and longer term decisions quite difficult, because you've got possibly, in worst case scenario, it would be a nightmare to me if there's 2 or 3 or 4 infrastructure owners or pockets of infrastructure owned by different people with maybe different objectives and directions, which means we don't always get the systems to align. Not wanting to be very, very techy, but if we've got a system here and a system there, we get to a point where they might need to speak to each other. If they're not really thought about, and that isn't really thought about, you end up with more costs because you've got to interface between those two. It puts a lot of pressure on maintenance, planning, and that's a difficulty. That's one my observations. I think an infrastructure owner is a pretty good model, and in other parts of the world they split infrastructure and operations, but there's only one infrastructure owner.
Yeah.
So that makes decisions
so
easier.
How do you, and this is slightly off topic but particularly relevant, what role does your organisation play in terms of, that harmonisation? So like in Europe, for example, this train from here can travel all the way through Europe, and there's a commonality in terms of being able to speak that signalling language all the way through the network. We're obviously going to have a need or a want here in South Africa to integrate with the rest of the region. So I'm assuming that you'll be able to provide quite a lot of knowledge sharing and information in order to facilitate that, because talking across the region, it's going to become a challenge.
Yeah.
And we're not as developed as the rest of Europe.
Sure. I mean, one of the beauties of the institution is that we are a totally separate organisation, and we provide independence, specialist knowledge, and access to knowledge, a body of knowledge that we've built since 1912,
yes.
As well as experts that have worked in many countries. And particularly as an example, what we've done recently, the government in the UK, and this could be put across different countries, but they've got a very difficult problem with crossing the railway. And if you've ever seen things about level crossings, particularly, they're very difficult things to control with cars, scooters, bikes, passengers. We have a particular problem in the UK where we have gated crossings, and signage and control of and information for the public is a real issue. And we've had deaths. There's no two ways about it. We've had really serious incidents, and the government proposed new signage and control for those. One of the bodies that they looked to comment on the government paper was the Institution of Railway Signal Engineers. So I, as president, formed a group of half a dozen experts to go through the proposals and the questions that were raised by government to comment. So that's the role that we can play, and that can be emulated in South Africa, it can be emulated in Europe, it can be in Australasia. We'll bring in that independence and opinion to help them. Obviously, we're an institution of railway signal engineers. We're not the government of the country. So the difficulty is each country will have a government and direction and funding and various decisions that they'll make. We will certainly give an opinion, and presently back in the UK we're quite vigorously making our opinion known about one or two issues to the infrastructure owner, because we've got concerns.
How many active members do you guys have globally, and also just bring it down to our Southern African section?
Yeah, I can proudly say for the last 3 years or so we've steadily kept our 5,000 membership worldwide, and in South Africa I'm going to quote the figure because I've talked to membership, because we're in the very period where people renew the membership, and we know what that figure is, and it's about 42 in South Africa. Skills
development and training our young signalling engineers, those that are coming into the industry. Foundation
of the institution, because obviously, again, different countries, different companies will have apprenticeship, graduate schemes, and as a pillar of what we provide, we have an exam organisation which is built into 4 modules where people can study, and in many of the local sections there'll be a study group where people will look at a syllabus for particular modules across the signalling discipline and the comms discipline. And every year in October there's an annual exam, and a route to our membership is for people to complete 4 of those modules. By the time that they've completed those modules, they'll be recognised at a member level, which really says you've studied to this level, your underpinning knowledge is at a certain point in your career. So that really supports aspiring engineers, young engineers, into the industry, along with apprenticeships, graduate programmes, workplace experience. So we fundamentally focus and offer that product, which is again done around the globe, because we keep it in a fundamental sense of the principles of signal engineering for people to be able to do it, and also align it to different countries will have principles. So the UK might have a set of principles, South Africa will have a set of principles, Australia, so it will differ slightly. We allow people to choose what standards they're answering the question against. We then have experts in that country that then mark the exam modules, and then people get their results in that way. But that's our route, one of our routes into membership level. And at the same time, particularly in the UK, but I'll bring the rest of the globe in shortly, but particularly in the UK, in the late 80s we had a disastrous accident which was caused by poor practices in the signalling arena at a place called Clapham Junction, just outside London, and over 30 people were killed. Sure. That was down to procedure, working practices, particular things, and again the IRSE got involved in the consequent reflections and reports, very famous in UK terms, but even in a worldwide sense. The hidden report highlighted and pinpointed what had gone wrong. Just for the audience, in the UK we decided then to privatise our railways, which gave us quite a concern about the people that were going to work on the industry at this field of something that could kill people in a very basic sense. So that we were asked to form a licensing scheme. So therefore, if you're going to work on in a particular discipline, let's say design for example, There's a license category which has performance criteria, and then there's a process of workplace assessment, competence assessment, to then actually be licensed in a particular discipline using design, but there's also installation, testing, maintenance in the categories, to assure the industry that we got people who were competent to do the role that they were actually being employed to do. The real good news over the last 2 or 3 years is that we're seeing interest in that around the globe, and we've got a lot of discussions ongoing with various countries, and one of the countries I visit very soon, in Kuala Lumpur, there's to give it a level of discussion, I'm going to be signing in a couple of months, a month actually, a memorandum of understanding for us to work with Kuala Lumpur University to align their content with the exam, and also to look at the licensing scheme to be placed in that particular region, to give the people in that region the surety of who's working on the system is actually competent to do that role, which is a key issue of making sure that we've got safe railways around the globe.
And it is a key thing, and it's a critical safety area, and I don't know if we have enough skills coming in from a South African perspective coming into or taking an interest in
I
becoming.
can tell you it's a worldwide challenge.
Okay.
Because in the UK we lose engineers on an annual basis, and we don't recruit enough graduates or apprentices. We know there's a gap, and I think that's a pretty similar field. I would say 1 or 2 countries, maybe Australasia, is doing a little bit better. It's a worldwide problem. And one of the joys of being here this week was to go to the Gabella plant to see a 48% female employee level, which was fantastic to see, and something we're deeply committed to improving in the institution, because our male to female membership is something that needs to improve. But yeah, to encourage people into engineering, and also female engineers, which was a little bit of a theme for my year, because I've had 2 eminent female engineers, one of whom I trained originally, to speak as part of my presidential papers. A president gets to deliver 7 presidential papers within a year, and I'm happy to say 2 of mine were female engineers. When
we say signalling engineer, or even the institute, railway signalling engineers, it's not just signalling. There are other subcomponents in there. Yeah. So unpack the word signalling.
You would talk about signalling and telecommunications, and actually they were 2 separate departments for many, many years. But as with the advancement of, and of course, remember we're in the business of advancing the science. But we talk about signalling telecommunications, but we talk about communications, train control, traffic management, and aligned systems, because signalling has changed from this is signalling, to then say, well, how are we going to control the system? Well, we've brought comms more into, so telecoms, communications has been brought far more into the signalling discipline, as well as employing, at a basic level, employing computers and systems to control trains, because traditionally we've had humans. But the problem with humans is that we're subject to error. There's a good debate between computers and humans, but that's another story. Yeah, and it's the question that all of this has become, and we very often now talk about the digital railway, more so in a lot of places. We're talking about passenger information systems, interactive comms, so we know how many passengers, we know loading, we know information. And the critical point you made, you do need somebody at a point to make a sensible decision, because in the very worst of context, people can get hurt.
Yes.
So we have to widen that a little bit to the communications market and the traffic management system. So, and also very traditionally, if you go along a very traditional railway line, you'll see people who don't understand railways deeply would think, oh, there's a traffic light there. That's communicating very key information to a driver of a train, because remember, as you said, if you've got 500 people on a train at goodness knows how many tons, in a lot of signalling systems still today, the driver is looking at an aspect in a signal which is telling them how far they can go and what they should be doing with their train as far as braking, controlling the train. What we're actually doing that is taking that from the track side and moving that into the train cab, because we've got the comms, because we've got Wi-Fi, because we've got internet, computers. We're putting information on the cloud, and we're putting a screen into the cab with the driver, giving them the information. And then most importantly, in modern systems, if the driver is doing something that shouldn't be doing, critical issue, going too fast, when they're going to somewhere where they should be stopping, that's a critical factor that's not going to work. We actually supervise the driver, and the system will brake the train to bring the train to a stop, because we know the drivers could be in trouble in some cases, and very simple things of a driver touching something every 15 seconds keeps the system aware that the driver's there, because worst case scenario, they could have a stroke, a heart attack, etc. So the trains systems are moving from trackside, and very pertinent for South Africa at the moment with what this industry is suffering. We're moving equipment that people vandalise or steal, which gives us horrendous problems and is giving the South African infrastructure that challenge right now, let alone the power system. We're moving that into the cab.
Yes.
And people will hear the phrase, but we start to talk about IRTMS, which is a European-based system, but is now going global. But it does fundamentally move an awful lot of trackside assets
into the train,
and into the
cloud. When we here in South Africa look at our signalling system and the rest of the region, being let's say Southern Africa, we're very different. Our technology is very different to what the European environment. From us catching up with the technology that is currently available versus what is coming. I mean, it's quite exciting that, I want to say Internet of Things, but it's not really. It's more than that.
More than that,
and the technology that's available. It's extremely exciting to see what's coming down the line and the impact that that's going to have on safety, but more so the impact that that's going to have on operational efficiencies. What for you do you think will be the most profound change in technology?
The most profound will be the final linking of the systems. But the criticality of something like IRTMS, for example, which moves a lot of equipment into the cab, but it actually gives us, in simple terms, we're very limited at the moment to a certain extent, because we've got two trains. We have to keep them separated by a set distance. We talk about, very often in basic terms, we talk about a fixed block. Imagine if you had a system where a train is going at X speed, the train that's following that train knows what that train's doing, because that's being communicated via a system, via a radio system and a comms system. If that train is going faster, this train can safely go faster, because in this train there's a computer that tells everything about that train and what it brakes like, and what it needs to do, and what that train's doing. And it's constantly in contact. We can actually move those trains closer together, and a big pull for everybody in any country in the world is capacity. You go to a country like Singapore, for example, imagine how many people live there, and getting them in and out of the city, you really have a capacity demand.
Yes.
But any system has got that, and even if you bring in freight as well, you can move freight more efficiently. We face a battle, but the most profound change will be the adoption of the technology and new rolling stock and new infrastructure. But actually the magic is they've got to happen at the same time. In the UK, we're probably going to see the best benefit of IRTMS over this year into next year, possibly, because we're renewing a whole section of track from London up towards past Peterborough, towards Doncaster on the eastern side of the UK. New track, new trains, new control systems, new passenger information systems, new train management systems. All of those things come together. The most profound change is when we actually get, dare I say, a government thinking, actually, if we do this all at the same time, we'll actually benefit massively.
Yes.
The battle is to persuade governments and people who control purse strings that is the way.
So as good as it can be, and taking into account all the safety and security benefits and efficiency benefits offered by the progress of technology, do we still need trained drivers?
The answer is no, we don't. In some systems, particularly where you're looking at when I say an enclosed system, but let's say a system where there's no other trains that interrupt my service and I go from A to B, let's say Johannesburg to Pretoria. If there were no other trains that crossed over me or caused me any, because obviously just think about a road, you've got a junction, you've got traffic coming this way, traffic going that way. It's more difficult than just going. If I've got a system that's just Johannesburg to Pretoria,
completely automated,
completely separate, doesn't have anybody disturbing it, doesn't have any level crossings, because we've got to make sure we get the other infrastructure things out of the way.
Yeah,
we could have a train that would be fully automated and wouldn't require a driver, and it would be perfectly safe.
Yeah, I just asked because I see a growing trend internationally for driverless trains, especially in the passenger sense. And then if we look at the project in Australia, that is a completely autonomous, I think is the right word, train from the mine to the port, and it works hella efficiently. I mean, there's just no other way about it.
Technical term is grade of automation.
There we go. Whilst they still have the train driver, his role has changed and it's actually become far more important, in my view. You know, the troubleshooting should something go wrong with the train.
Yeah, I mean, the big misconception, if you say driverless to a lot of people, I mean, particularly drivers, let's say, for instance, because you get down to union level, the actual reality of driverless trains, for example, is that you don't have the massive reduction in staff that you think you would have. People need to be deployed for separate duties and slightly different duties. And to put it in context, we've had driverless trains in London, let's say, for example, on the Underground since about the late 60s. But it's because we talk about this grade of automation, because what you can have is a driver in a cab who is watching the information that they've got on the screen and may be responsible for opening the doors at the station, making sure the passenger's safe and then closing the doors. As you increase that automation, that just gets done automatically. And then ultimately you remove the driver. For the audience, if you go to London and go on the Docklands Light Railway, that is a totally driverless system. If you go to Denmark and go around the suburbs of Denmark, you've got a completely driverless train. There are no drivers in the cab. And of course you've then got very tried and tested systems that brake the train efficiently, stop it at the station, open the doors, close the doors using sensors, cameras, etc. But yeah, it is possible.
Andy, thank you very much for your time.
You're welcome.
Wish you well. I look forward to supporting the Institute as we go forward, and I look forward to seeing new signalling engineers come through into the market as technology gets more exciting.
Okay, thank you.